So okay students, now let's do the next question. Okay, here obtain the Norton's equivalent for this is a circuit. Okay, and here this is the two terminals, right? The open terminals A and B. So first thing what I do is that I just simply join these two terminals. Okay, so let me write joining AB comma, what will happen? This is the same current source. Let me draw it very fast, okay, so that I don't have to take too much of time for this. This is the resistor, this is the inductor, okay, and here you have the inductor, okay, here you have the capacitor, and here you have the another inductor, okay. This is the circuit. This is 3J, this is 5J ohm, this is minus 5J ohm, this is 2J ohm, this is 5 ohm, and this is 10 angle 0 degree amperes. Let's join here also, okay. So which means now what I'm going to do, sir, I need to short these two. So by shorting these two terminals, this is the branch, and the current through from A and B, right, that this current, this is called as IN. So your job is to find the value of this value IN. So I'm going to apply Norton's, I'm going to apply mesh analysis. So therefore 3 meshes, let this be mesh 1, so this is I1, let this be mesh 2, so this is I2, and let this be mesh 3, and this is I3. Okay, so basically you have not learned anything new over here. So here also you are applying mesh analysis, okay. And one more thing is that you don't have to find the value of I1 and I2, right? See, because if you look over here, you need to find the value of IN, right? So the current through this branch is IN, and according to your mesh currents, the current through this branch is also called as I3. So basically I3 is equal to IN. So which means if you found the value of I3, you have found the value of IN. So your job is to find the value of I3. Okay, so let me write the equation for mesh 1. So equation for mesh 1. Okay, so here the equation for mesh current is very easy, right? Because there's already a current source over here, which means the current through this branch is 10 angle 0 or 10 amperes. 10 angle 0 is 10 amperes. And also the current through this branch is also called as I1. Both of them are flowing the same direction, upwards. So in other words, I1 is equal to 10. Very easy, right? This is the equation for mesh 1. Next I'm going to write the equation for mesh 2. So equation for mesh 2. Okay, so if you look at mesh 2, here I2 is considered positive, I1 and I3 are considered negative, so therefore minus I1 into, and in mesh 2 I1 is touching only this resistor, right, 5 ohm. So this is minus I1 into 5 plus I2 into, and this, and for I2 it is touching these 4 elements, right, this 5 ohm, this 3J, this minus 5J, and this 2J. So here only this 5 ohm is the real part, and what about the imaginary part? You have 3 minus 5 is minus 2, minus 2 plus 2 is 0, which means this is basically, there's no imaginary part. All these 3 elements will cancel each other, right? So you have no imaginary part. So this is only this much, 5 plus 0 J's, so this is 5. Now next is I3, and in I3 is also negative, so it is minus I3 into, and I3 is touching only this capacitor, and the value of this capacitor is minus 5J, so it is minus I3 into minus 5J is equal to, there is no voltage source over here, so this is equal to 0. This is the equation for mesh 2. Okay, this equation is divisible by 5, right? See, this equation is divisible by 5. So if I divide this entire equation by 5, I will get minus I1 plus I2, minus of minus becomes plus, right? So this is plus I3 into J is equal to 0. So this is equation 2. Okay, so this will be my equation for mesh 2. So now I'm going to write the equation for mesh 3. Okay, so the equation for mesh 3, let me write equation for mesh 3. Okay, so to find the value of equation for mesh 3, this is the equation, and here I2 is considered as negative, so it is minus I2 into minus I2 into, and this I2 is touching this capacitor, only this capacitor. In mesh 3 I2 is touching only this capacitor, so it is minus 5J. So minus I2 into minus 5J plus I3 into, and this I3 is touching this two elements. This is 5J and minus 5J. Okay, so that's very interesting. This is 5J minus 5J, right? I3 is touching these two elements, right? So this is 5J and this is minus 5J, right? And there is no voltage source over here, so this is equal to 0. This is the equation for mesh 3, right? This is the equation for mesh 3. Minus or minus is plus over here, right? So this is I2 into 5J, and here plus I3 into, this is 5J minus 5J is 0. So this is I3 into 0 is equal to 0. I3 into 0 is 0. So therefore you have I2 into 5J is equal to 0, or you have I2 is equal to 0. So this is the value of I2. I2 is equal to 0, which means there is no current called I2 in this circuit. That's what it means, right? So which means I need to substitute the value of I2 over here. I need to substitute the value of I1 over here. So what is the value of I1? I1 is 10, right? So let me write like this. Let this be equation 3. So I'm going to say that substituting equation 1 and 3 in equation 2. So I get, here is, so this is I1 is 10, so you have minus 10 plus 0 plus I3J is equal to 10, sorry, is equal to 0, right? Is equal to 0. Then in that case, what is I3 into J? I3 into J is equal to 10, or in other words, I3 is equal to 10 by J, or it's also called as minus 10J. Okay, minus 10J. So what is minus 10J? Let me see. Minus 10J is nothing but option in polar form. It is 10 angle minus 90 degrees. So this is 10 angle minus 90 degree amperes. This is the value of I3. Therefore, the value of IN is also equal to 10 angle minus 90 degrees. Okay, so now you found the value of the Norton's current. Next you're going to find the value of the Norton's impedance. Okay, so to find the Norton's impedance, what you need to do is, if you see any voltage source, you need to short it, and if you see any current source, you should open it. So since in the circuit there's only one current source over here, right, in this branch, which means this branch will be open, right? So what will be your circuit look like? That is, to find Norton's impedance, this branch is entirely open, so therefore no current will flow in this branch, right? So this, basically you don't have to draw all this. So this starts with this resistor 5 ohm and this 2J, 5 ohm and this 2J. Okay, then you are having a 3J ohm over here in parallel. So this is in 3J. Actually, I'm not supposed to say in parallel. This is not in parallel. This is 3J, and this you have a capacitor over here. The capacitor is minus 5J. Okay, and you also have an inductor over here, and this inductor is 5J, this inductor is 3J. So this is 3J and this is 5J, and you are supposed to find the impedance between A and B. That impedance is called as ZN. Okay, this is basically, it's the same as finding the value of ZTH, right? It's basically the same as finding the value of Thevenin's impedance. Same procedure. Since this current source is open, right? So which means this entire mesh will disappear, right? Because no current will flow, so that therefore this entire branch will be open. So you don't have to draw this branch, right? There's no need of drawing this branch. So this will be a resulting circuit. So now you need to find the equivalent impedance between A and B. Okay, so what will be the first thing I will do? First thing I will do is that, if you can look over, if you see over here, this is very easy. Look over here, this 3J, this 5 ohm and this 2J. I repeat, this 3J, this 5 ohm and this 2J. These three elements are in series, right? If you look at these three elements are in series. How I know it's series is because the same element, the current that is flowing through 3J is the same current that is flowing through this 5 ohm and it's the same current that's also flowing through this 2J, right? Same current is flowing through this 3J, 5 ohm and 2J. So therefore these three elements are in series, right? These three elements are in series. So which means basically we have 5 ohm plus 3J plus 2J, which is equal to 5 plus 5J, right? You have basically 5 plus 5J ohm. So which means now your circuit will become like this. That is, the equivalent impedance is called as 5 plus 5J. So which means you have a 5 plus 5J over here. Okay, you basically have a 5 plus 5. This entire circuit is replaced by 5 plus 5J. Now you have a inductor which is also 5J. Okay, this is also 5J, and also you have a capacitor also, right? And this capacitor is connected like this, right? So this is the capacitor. See, because this terminal is also connected to B, this terminal is connected to B, and this terminal is also connected to B, right? So therefore these two terminals are same junction. All of them are connected to B, and this is capacitor is minus 5J. Okay, so you can see this capacitor and this impedance both are in parallel to each other, which means I want to combine these two. So if I want to combine these two, it is minus 5J into 5 plus 5J divided by minus 5J plus 5 plus 5J. This minus 5J plus 5J will cancel each other, and here you have minus 25J, and here it is J into J is minus 1, so minus 1 minus becomes plus, so you have plus 25 divided by this minus 5J plus 5J will cancel, so you have only left with 5. So therefore this is nothing but 5 minus 5J, right? 5 minus 5J. So if you combine these two, you will get 5 minus 5J. So therefore your equivalent circuit will now become another impedance whose value is 5 minus 5J, and you have the same inductor over here also. This is terminal A, this is terminal B, and this is 5J, right? This is 5J. So now if you look over here, these two elements are in series, right? Because the current that is flowing through this inductor, through this 5J inductor, is the same current that is flowing through this impedance, 5 minus 5J impedance. So which means these two elements are in series, right? So that is your Norton's impedance, or Norton's impedance is equal to 5J plus 5 minus 5J. This is your Norton's impedance. Okay, my 5J and minus 5J will cancel each other, which means you have only 5 ohm. So which means this is basically a resistor, right? This is basically a resistor. Not here in this question, the Norton's impedance is actually a 5 ohm resistor. Okay, so this is your answer. So let me draw the Norton's equivalent. First I draw the current source, okay, and then I draw the impedance or resistor. You can either draw an impedance or resistor. If drawing the resistor is also correct, because this is basically a resistor, right? 5 ohm. So this is your answer. Okay, A, B. So this is Zn is equal to 5 ohm. And what about Norton's current? Norton's current is 10 angle minus 90 degree. It is IN is equal to 10 angle minus 90 degree amperes. Okay, this is the circuit, Norton's equivalent.